Alright, so in this video we go over section 1.2, quadratic equations. So in this section we are going to review all methods to solve quadratic equations, which is factoring, the square root method, completing the square, the quadratic formula. Alright, so let's begin by solving quadratic equations by factoring. First of all, let's define what a quadratic equation is. So a quadratic equation is an equation that has this form. The reason why we call it squared is because the highest exponent is 2. Or the degree of the polynomial equation is 2, right? In this case, a, b, c are real numbers as long as a is not equal to 0, because if a equals 0 we would get only a linear equations, which are the ones that we already covered in the previous section. Alright, let's solve equations by factoring. So in this case, if we look at this polynomial, we can factor out the GCF, which in this case is 1 power of x. Okay, so factor out the x times x plus 6 equals the 0. Okay, so in this case, what we do after doing the factorization, we set each factor equals 0 and solve each baby equation. So in this case, well, x equals 0, we're done. X equals 0, that's one of the solutions. The other solution we get x plus 6 equals to 0. So in this case, subtract 6 on both sides. Okay, subtract 6 on both sides to you get x equals negative 6. Okay, so that's one solution. Okay, x equals 0, and the other solution is x equals negative 6. Alright, let's look at the other example, example B. First of all, for letter B, how is that different from the previous example? Well, the main difference is this equation, it's not in the form that we described in the box above, in which we have all the terms on the left hand side in descending order of powers, exponent 2, exponent 1, and the constant term. So we need to do some work before we can get this equation solved. So let's go ahead and solve this equation and move the x and the 3 to the other side by subtracting x on both sides and subtracting 3 on both sides. Okay, so in this case we get the x's cancel and the 3's cancel. We get everything cancel on both sides. So we get 0 on the left hand side, the right hand side, sorry, and then 2x squared minus x minus 3 on the right hand side. Alright, now we need to look for a suitable method to factor this trinomial. So there are different methods to factor trinomials in which the leading coefficient is different than 1. In this case it's 2. Otherwise it would be just factors of negative 3. If we didn't have these 2, if it were 1, we would look for factors of negative 3 that add up to negative 1. Well, in this case there wouldn't be any. However, in this case we are going to use a different method. Well, depending on how you learned your factoring, whether in high school or in a previous intermediate algebra course in college as well. Well, so there's two ways to solve this, to factor this type of polynomials. Number one, by trial and error, and the other way by the diamond method. I prefer doing the diamond method because I think it's a more systematic way that leads us to straight to the final answer, instead of doing trial and error one time and another until we get the desired result. So how do we perform the diamond method? Well, first of all, let's draw a diamond here. Okay, so I'm going to multiply the leading coefficient with the constant terms. So that is 2 times 3. That's going to give us the number 6 in here, negative 6 rather, because positive times a negative, it's going to give us a negative. And we are going to bring down the middle coefficient. What is the coefficient of x? Well, we just have a negative sign in front of the negative x, which means that negative 1 is its coefficient. So now we are going to look for factors of negative 6 that add up to negative 1. Well, 6 times 1 is 6, 6 minus 1 is 5. No, this is not going to work. Another way to factor the number 6, well, how about between 3 and, let's see, 3 and 2. Between 3 and 2. So, however, in this case, well, one of them has to be negative so that the product is a negative number. On the other hand, we need to make sure that when we add them, we get a negative number. So the largest number has to have the negative sign, because negative 3 times 2 is negative 6, but negative 3 plus 2 is negative 1. Okay, but what are we going to do with these two numbers? Okay, we use these two numbers to split in either order. You can put the negative 3 and the positive 2, or the positive 2 and then the negative 3. I'm going to put 2x and negative 3x. And then I'm just going to keep the other two terms, the 2x squared, which is right here, and the negative 3, which is right there. Set that equal to 0. Okay, let me delimit this so we don't get confused about our work here. Alright, so in this case, well, we have, what do we have? Well, we have 4 terms. So to factor up a polynomial with 4 terms, we are going to use factor by grouping. So we get the GCF of each group. That is going to be 2x times x plus 1. And factor out a negative 3 times x plus 1. And then we will do a final GCF, which is x plus 1. So we are going to get the following. We're going to get 2x minus 3 times x plus 1 equals to 0. Okay, so I'm running out of space below here, so I'm going to write the each factor. 2x minus 3 equals 0, and x plus 1 equals 0. That is by the zero product property. The zero product property establishes that if we have a product of factors here, of course, equal to 0, either 2x minus 3 equals 0 or x plus 1 equals to 0. So let's solve each individual equation, add 3 to both sides. Over here to get 2x equals 3, and finally divide both sides by 2. So in this case, the 2's go away, they get cancelled, and we get x equals to 3 halves. So that's one of the solutions, 3 halves. On the other hand, the only thing we need to do, just subtract 1 from both sides to get the 1's cancelled, and get x equals negative 1. So as expected, well, because the equation is quadratic or second degree, we are going to obtain two solutions. Alright. Now let's look at another method to solve quadratic equations. Let's review this method called the square root method, in which we have the simplest case of equation in which the term to the first power doesn't appear. So that's going to be one of the simplest methods. Let's see it in action. So essentially, all we do is, when we have x squared equals some number p, which is what we have, all we do is take the square root on both sides, provided you put plus and minus in front of the p. So in this case, x, the root cancels the square, and we get x equals plus or minus the square root of p, which is the minus and the plus right here. Okay, let's look at a couple of examples about this. Solve each equation. So what do we have here? Alright, so all we do, okay, let me write the equation again, and I'm going to leave some space here because I'm going to need space for the plus or minus sign. So in this case, the radical cancels the exponent 2, okay, and we get x equals square root of plus or minus the square root of 5. That's all it is. But we need to break this one into two x's. x1 equals the negative root and x2 equals the positive root. Why is this happening? In case you were wondering why that happens, okay, let me go up here and explain that. So we have x squared, the square root of x squared. Every time we have a square root, there is an invisible number here, an invisible 2. Okay, if we rewrite that using rational notation, x squared, rational exponent notation, this is the same as saying 1/2. Now, in this case, we have the power of another power. So when we have the power of another power, we multiply the power 2 times a half. But notice 2 times a half results into a 1, which is simply x. So that's why we can just cancel the radical with the square, the radical index with the square, as long as they are the same number. All right, let's have a look at another example. So we have x minus 2 squared equals 16. So what am I going to do? I'm going to take the square root on both sides. Let me write it again first because I need space for these symbols. So what we do is do the inverse operation to the square, which is take the square root. Alright, but don't forget the plus or minus here. And in this case, we may cancel the radical with the square. So we are going to get x minus 2 equals plus minus the square root of 16. So in this case, we know that the number 16 is a perfect square. In other words, there is a number whose square is the number 16. In this case, the number 8. As opposed to the previous example, I left it only as a square root of 5 because the number 5 is not a perfect square. All right. So now that we are ready to get x by itself, let's add 2 to both sides. But be careful here, do not add the 2 with the 8th, because the reason why we cannot do that is because of this plus minus symbol. This plus minus symbol, we can't do that, okay? I will show you what we're going to do next. So in this case, cancel these 2's and get x equals 2 plus minus 8. So from here we are going to get x1 equals 2 minus 8 and x2 equals 2 plus 8. In the first case, x equals 1, x1 equals 2 minus 8, which is negative 6. That's one solution. And 2 plus 8 equals 10. That's the second solution. Quadratic equation, 2 solution, x1 and x2. Alright. Let's look at another example. Letter C. Well, so we want to isolate the quadratic term. In this case, in cases A and B, the quadratic term was already isolated, was already by itself, right? What is the quadratic term? Is whatever algebraic term that is raised to the second power. So add 4 to both sides in order to cancel the number 4's. So 3x plus 1, quantity squared, equals 17 plus 4, which is 21. And notice the space I'm leaving for the upcoming symbols. So 21. So take the square root on both sides, but don't forget the plus minus on the right hand side of the equation. So we may now cancel the radical with the square to leave us with the 3x plus 1 equals plus or minus the square root of 21. In this case, we are going to leave it like this, because the number 21 is not a perfect square. We just leave it as indicated. We don't do decimals. On the homework, you are going to be asked to represent final answers in terms of radicals, unless otherwise specified, like reporting your final answer using 2 decimal places or something, but not in this case. So let's continue isolating the x by subtracting 1 to both sides of the equation. 3x equals negative 1 plus minus the square root of 21. And finally, we are ready to divide both sides by 3. But in this case, I'm going to divide here and there instead of a single bar. That's going to be useful when it comes to express both x1 and x2. So we get the 3's cancel, x equals negative 1/3 plus minus square root of 21 divided by 3. Notice the division by 3 is not inside of the radical. You need to be careful here when you are writing your solution, when you're doing the homework. Try your best to write as neat as possible, because if you write, well, number 1, square root of 21 divided by 3 is not the same as square root of 21 over 3. And sometimes we are in a hurry, or sometimes we have a sloppy writing like mine. Of course, I agree it's not the best. And we write something like 21 over 3. And it's not very clear, like in this case, it's not very clear whether the 3 is inside or outside the radical. So be careful with this. Be careful when writing your steps. Okay, so now we are ready to write every single solution to this problem. Okay, let me delimit these two. Okay, so x1 equals negative 1/3 plus, first the minus, I write the minus first, square root of 21 divided by 3, and x2 equals negative 1/3 plus square root of 21 over 3. Final answer, final answer. So this is everything regarding solving quadratic equations using the square root property. In the next topic, we are going to learn how to complete the square in one variable. All right. What does it mean to complete the square? Well, so we are going to do a process. First of all, let me do something on the side real quick. Well, so give me a second here. All right, let me do something real quick on the side. You might remember the squared binomials, for example, x plus 2 squared. One way to expand this binomial is by foiling. That's one way. Let me go that route. X plus 2, x plus 2. And then FOIL x times x, that's x squared. X times 2, that's 2x. 2 times x, that's another 2x. And 2 times 2, which is 4. Which this reduces to x squared plus 4x plus 4. An alternative way to, in general, when we have a plus b, is square root of the first term plus 2 times the product of the first and the second plus the square root of the second term. So in other words, we just do x squared plus 2 times 2, which is 4, times this x, which is 4x, and then the square root of the second term. Isn't it the same? Right? And this is called a perfect square trinomial. And the reason why it's a perfect square trinomial, well, it's because we can go back and write it in a binomial square like this. For example, x squared plus, let's see, 10x plus 25. Okay, how do we know if this is a perfect square trinomial? So what I will do here, take the square root of the first term, or in other words, what quantity squared is equals to x, so in this case x, what quantity squared equals 25, that's the number 5. Multiply these two, x times 5, and then multiply by 2. Do you get the middle term? Yes, 2 times 5 times x equals 10x, which is this guy in the middle. And then we factor like x plus 5 quantity squared. And you can expand this guy, you should get that one again. Alright. What else do we do? Let me make something up again. What about x squared plus 12x plus 36? Let's see, is this a perfect square trinomial? Well, what quantity squared equals x squared? That's x again. What about this one? That's 6. Okay, x times 6, that's 6x. Multiply that by 2. Do you get the middle term? Yes, 2 times 6 times x. So this is a perfect square trinomial. Alright? That's a perfect square trinomial, which can be factored as x plus 6 quantity squared. If you want to FOIL this, to expand it, you should get this one back again. Now, let me flip this paper. What about x squared plus 16, x plus 25? Alright, again, let's determine whether this is a perfect square trinomial. What quantity squared equals x squared? Well, that's x. What quantity squared equals 25? Well, that's 5. Now, let's multiply 2 times these two quantities, 5 and x. In this case, we get 10x, which in this case, these two guys are not the same. So, this is not a perfect square trinomial. We'll just use PST for short. Alright. However, we are going to do an operation to somehow add a number in order to turn this into a perfect square trinomial, which is called, that operation is to complete the square. Alright, so what are we going to do? We are going to focus on the coefficient of first degree, that is the middle coefficient, right? The number that multiplies x to the first power. Divide the number, multiply that by a half, and whatever you get, square it. Okay? So, let's see. We are going to multiply 1/2 and then square. We are going to multiply 1/2 the number 8. In other words, 8 divided by 2, that's going to give us a 4. 4 squared, which equals 16. And that's the number that we are going to add. So we have x squared plus 8x plus another quantity that completes the square. That's plus 16. Now, how do we factor this? X plus 4 equals, x plus 4 to the second power. We're going to do a bunch of this for practice. Okay, let's do the same for the second example. I'm going to multiply 1/2 times the middle coefficient and then square. But what is the middle coefficient in this case? The number 12. So 12 divided by 2, that's going to give us a 6. Quantity squared equals 36. So the quantity that we need to add to these two terms in a way that the result is a perfect square trinomial is the number 36. Wait a minute. Isn't that the same example we did over here? Alright? But in this case, it was given that it was a perfect square trinomial, and we went on to just factor in as a binomial square. In this case, we were not given that information. It was our job to find that number, that quantity, that when we add it together with these two terms, that results into a perfect square trinomial. Quantity squared. Alright? Okay, let's do the next one. So, 1/2 squared. Now, notice something different here. Notice the negative sign. So in this case, I will just omit the negative sign. I mean, if you want to write it down, it's up to you. But the thing is, when I write it down, I will have too many parentheses and it's just going to look so messy. And the reason why this is not necessary is because ultimately we are going to square this quantity, and any number that you square, whether this is positive or negative, it always turns into a positive quantity. So 20 divided by 2, that's a 10, and then square it, that's going to give us 100. So we get a squared minus 28 plus 100. So that's going to be a perfect square trinomial. Now, the way we are going to factor this is going to be a little bit different. Not that different from the previous two. So first of all, the quantity whose squared is a squared. That is just a. And the quantity whose squared is the number 100 is 10 squared. In this case, we are going to put the sign of the middle term. Okay, let's recap this. We have a perfect square trinomial. How do we factor? Basically, the square root of the first term. What is the square root of x squared? X. The sign of the middle term, which is positive. The square root of 16 for everything squared. Square root of the first term, which is x squared. That was supposed to be, my bad. That was supposed to be y, not x. Alright, that was supposed to be y. The square root of y squared is y. The square root of 36 is 6. Sign of the middle is positive. Square root of a squared is a. Square root of 100 is 10. Sign of the middle, negative, the whole thing squared. Alright, let's look at other examples. Let's look at the fun examples now. Examples in which not everything is going to be sunshine and rainbows in terms of numbers. So we are going to get some kind of wacky numbers here, because the number 5 is not divisible by 2. In other words, if we multiply the number 5 by 1/2, we are going to keep it as it is, no decimals. So number 1, 1/2, and square it. So we are going to multiply 5. Well, in this case, 5, like I mentioned before, 5 is not divisible by 2, so we are just going to keep it as it is. Multiply 5 times 1/2, that's just 5 halves. Quantity squared, that's going to give us 25 fourths. So the result of this will be p squared minus 5p plus 25 fourths. Factor form. Square root of the first term, which is p, sign of the middle, square root of the third term, square root of 25, which is 5, square root of 4, which is 2, the whole thing squared. Alright? Now, let's move on to the last example, which is going to be the wackiest of all of them. Alright, so 1/2 space squared. The space is meant for the middle coefficient, 7/3. Alright. So first of all, before squaring anything, again, keep in mind PEMDAS. We do the quantity that is inside of the parentheses first. That is the higher hierarchy in the order of operations. 1 times 7, that's 7. 2 times 3, which is 6. Quantity squared, that's going to give us 49/36. Yes, not the prettiest number. So that's the quantity that we are going to add over here. X squared plus 7/3 x plus, in this case, 49/36. This is going to result, okay, the square root of the first term, the sine of the middle, the square root of the third term. Square root of 49, that's 7. Square root of 36 is 6. The whole thing squared. Alright. So that is just that is just preparing a polynomial, a potential polynomial, to turn it into a perfect square trinomial. Now we are going to use this piece of information, this thing we just reviewed here, in order to solve quadratic equations by completing the square. Alright, so first of all, before looking at an equation, before attempting to complete the square at all, we need to move the constant term to the right hand side. And if the leading coefficient is different than 1, we will then need to divide. So I'm going to do one example of each. Okay. Yes, I know what you are thinking. This one goes really easy by factoring. Factors of 4 that add up to 5 are 4 and 1. So the solutions are -4 and -1. However, in this case, we're going to solve it by completing the square. Alright. So let me subtract. Let's subtract 4 on both sides of the equation. Cancel those 4's. And we get x squared plus 5x. I'm going to leave a space here, equals -4. Now, what's the next move? The next move is to add a magical mystery number. What is that magical mystery number? The number that when we add it here, this is turned into a perfect square trinomial. How do we find that magical mystery number? I'm going to denote it M. Big M. Big M is a number 1/2 times square it. That is the number that we multiply by 1/2 and square. We already did this one, 5/2 squared. That's 25/4. Alright. Okay, so from here we are going to add that magical mystery number, 25/4. 25/4 again. Keep the same idea when we are solving equations. Whatever number you add on one side of the equation, it must be then added into the other side as well. Okay, so that's the work to turn this into a perfect square trinomial. So now let's factor out the polynomial by, so square root of the first term, sine of the middle, square root of the third term, which is 5/2 quantity squared. And then over here, just add the numbers. So let's see, 25/4 minus 4. I get 9/4. by combining these two numbers. Okay, I left a little bit of space here because the next step is to get rid of this squared over here. And we do that by taking square root on both sides. However, be sure to put the plus or minus on both sides. Cancel the squares. X plus 5 halves, oops, different color, wrong color, x plus 5 halves equals plus minus. The good thing in this case is 9 and 4, both of these numbers are perfect squares, plus minus 3 halves in this case. Alright, so what are we going to do next? Next move the 5 halves to the other side. Oops, it's just minus. Cancel this 2. And we get x equals negative 5 halves plus or minus 3 halves. Alright, so that's what we get. On the one hand, we are going to get x1 equals negative 5 halves minus 3 halves, which is negative 5 minus 3. That's going to give us negative 8 halves, which is negative 4. So that's one solution. On the other hand, x2 equals negative 5 halves. Now we do the plus 3 halves. So what are we going to get? Negative 5 plus 3, that's going to give us negative 2 halves, which reduces to negative 1, which is the same result you would obtain if you did this using factoring. Alright, let's see. Let's do another example. Alright, first of all, for the next example, let's add 5 to both sides. This will cancel this 5 with the negative 5. 2x squared minus 8x equals 5. Right? Now, going back to the blocks above, we need to leave the equation in this form. It's not yet in the desired form. So what's special about this form? Leading coefficient must be 1. Actually, the arrow should have pointed over here. Okay, it must be a 1. In order to get that, so we will have to divide both sides of the equation by 2. Okay, so that's going to give us x squared minus 4x. I'm going to leave some space here, equals 5 halves. Okay, I don't want to run out of space below. I'm going to do this calculation of the big M, the magical mystery number, over here. That's going to be 1/2 quantity squared. What is the number that we are going to halve and the squared? The number 4. Again, you can ignore the negative sign because we are going to square this quantity over here. 4 divided by 2, that's 2, squared, that's equal to 4. So, we need to add a quantity to both sides of the equation. That is the number 4. Why is the number 4? Because that's the number that will turn this into a perfect square trinomial. And we already factored this one before on the examples in the boxes above in the previous page. X minus 2 squared equals 4 times 2, that's 8 plus 5 equals 13 halves. Alright, let's see. Now notice the space I left in here again. They have a purpose. To leave space for the radical and to write down those plus or minus signs. Now let's keep going with this. X minus 2 equals plus or minus. Okay, I'm going to do something over here. I'm going to use the property of radicals that states that when we have the radical of a quotient, we can write this as the quotient of two radicals. Okay? I'm going to fix this. I'm going to rationalize the denominator. What is rationalizing the denominator? So from intermediate algebra, you might recall to multiplying numerator and denominator by the same denominator in order to cancel the square root. So square root times itself, the radical cancel, and that's going to leave us with, in the numerator, plus minus, I'm going to keep this negative 2 for a second. That's going to be 13 times 2 and divided by 2. X minus 2 equals plus or minus the square root of 26 divided by 2, and then all we do is add 2 to both sides. Alright, so we are almost there to get our final answer. So cancel this to get x equals 2 plus or minus the square root of 26 divided by 2. Okay, let's cancel the x's. Alright, so look at the funkiness of these numbers. So when submitting your work on my MATLAB, just leave it as it is. 2 minus square root of 26 divided by 2. Leave it like this, unless you were asked to report as a final answer one with decimals. x2 equals 2 plus square root of 26 over 2. And that's final answer for this one. Alright, so these two were examples on how to solve quadratic equations by completing the square. Right? The next method to solve quadratic equations is using the quadratic formula. And typically this is relatively easier to do because all we have to do is just plug in numbers and keep simplifying. All we need to be careful here is that the equation is written in the correct form. That is, everything is on the left hand side of the equation. Alright, otherwise we would need to do some algebra, move some terms around to the left hand side, and be sure that 0 is the right hand side. Alright, number 1, first thing we do, identify a equals 3, b equals negative 5, in this case we consider the sign, and c equals to 1. Alright, so we are ready to just plug in the numbers in the quadratic formula. X equals minus b plus minus square root. I like writing the formula first, that way we can follow the work along. Alright, so minus 4ac, the whole thing divided by 2a. So minus b, which is negative 5. Careful. Plus minus the square root of negative 5 quantity squared minus 4 times the quantity a, which is 3, times the quantity c, which is 1. Whole thing divided by 2 times a, which is 2 times 3. Over here, minus minus, use the smile rule. If you haven't heard of the smile rule, do you see the smile here? I can see it. What does that mean? Smile be positive. That's why negative times a negative is positive, right? That's a silly joke, but it typically helps to remember what happens when we have a negative in front of a negative of another negative. All right. So this is going to be 5 plus or minus the square root of negative 5 quantity squared, that's 25, minus 4 times 3, which is 12. 2 times 3 in the denominator gives us a 6. And we're almost there. 5 plus or minus 25 minus 12. That's going to give us 13. And in this case, we have one of these wacky looking numbers. Alright, so what are we going to do here? Simply x1 equals 5 minus square root of 13 over 6, and x2 5 plus the square root of 13 divided by 6. 1, 2. Okay. All right. Let's see. Let's do another example. Letter B. So for letter B, notice you have a fraction here. All right. Now think about this. I don't think. Well, in the first place, fractions are not our favorite numbers, right? I mean, sometimes we have to deal with them. There's no way around. However, think of plugging this 25 halves over here. That is, you're going to end up with fractions inside radicals. That's going to look even uglier. What are we going to do in this case? I'm going to multiply both sides by 2, which is the LCD essentially. So over here they cancel, leaving us with 25x squared, and then distribute 2 times the negative 30, that's 60. Negative 60x, and 18 times 2, that's a 36. Alright, and now we are ready to solve this equation. Yes, it's going to have a little bit of big numbers, but we're going to get there. Okay, so let's write down the formula first. Minus b plus minus square root of b squared minus 4ac. The whole thing divided by 2a. So minus negative 60. Okay, this is b. Let's write them down first. A equals 25. B equals a negative 60. C equals 36. Okay, so again, this smile rule is going to get in handy here again. So minus 60 squared minus 4 times A, which is 25, times C, which is 36. The whole thing divided by 2 times A, which is 2 times 25. Alright, again, like I mentioned before, this turns into a positive. That's going to be 60 plus or minus the square root of negative 60 squared, which is 3600, minus 4 times 25, which is 100, times 36, that's also 3600. Oh, look at this. divided by 50. 36 minus 36, they cancel each other. It's not going to be as ugly as it looks. 60 plus or minus the square root of 0 divided by 50. But what is the square root of 0? That's still 0. But adding 0, subtracting 0, do we really need to keep that plus minus 0? No, we don't need to have that. 60 divided by 50. That is our solution. Alright, in this case it's only one solution. However, we need to keep simplifying this. These are both divisible by 10. So final answer 6/5. Okay. Now, let's look at another example. Another equation that looks like quadratic, but it's not in the correct form. So what do we do here? In this case, notice the x's are in the denominator, so I'm going to multiply both sides by the LCD, which is the highest power of x. In this case, multiply both sides by x squared. So what am I going to get? So I'm going to distribute x squared times 9. That's going to give me 9x squared plus, I'm going to multiply 3x squared divided by x, and finally I'm going to multiply x squared times 2 minus 2x squared divided by x squared. So in this case, x squared divided by x, this is going to give us 3x, and in this case the x's, the x squareds are going to get cancelled. Alright, so now the equation is in the correct form, in that form that we need in order so we can use the quadratic formula. So a equals 9. By the way, my handwriting sometimes makes my a's look like 9s. I'm trying to be as clear as possible. B equals 3 and c equals negative 2. So x equals minus b plus minus square root of b squared minus 4ac, whole thing divided by 2a. So minus b, in this case minus 3 only, there's no negative, no smile rule in this case like in the previous two examples. Minus 3 squared minus 4 times the quantity a, which is 9, times c, which is negative 2. Divided by 2 times the quantity a, which is 9. Okay, so let's keep simplifying this. Negative 3 plus or minus 3 squared, which is 9. And then be careful here. Look at negative times a negative. That's going to give us a positive. 4 times 9, that's 36. 36 times 2, that's going to give us 72. Okay. 2 times 9, 18 in the denominator. And then when we simplify the inside of the radical, we're going to get square root of 81. Nicer numbers in this case, indeed. Square root of 81 is 9. So now we have everything ready to establish our x1, which is negative 3 minus 9 divided by 18. On the other hand, x2 equals negative 3 plus 9 over 18. Negative 3 minus 9, that's going to give us negative 12 over 18. In this case, both numbers are divisible by 3, I believe. So I'm going to state the division by 3. Alright, so that's going to be x1 equals 12 over 3, that's 4. 18 over 3, that's 6. Alright, these are both still divisible by 2. So let's divide both numbers by 2 to get x1 equals negative 2/3. Final answer. What about x2? 9 minus 3. It's positive 6 over 18. These are both divisible by 6. This is x2 equals 1/3. 2 solutions. So this is the end of section 1.2 quadratic equations. In the next section in which we are going to talk about complex numbers, we are going to go back to quadratic equations in which the solutions that arise are solutions in the complex number system. See you in the next video.